Greetings! If you watch this video until the end, you will learn what is object-oriented programming, how OOP emerged, and how OOP basically works. So let's start from the very beginning and talk about programming paradigms. What are they? So in general, it's a style or method of building software. It defines how a programmer thinks about the structure and behavior of programs. And I think that the most well-known paradigm in programming, it's a functional paradigm when we try to build our programs by functions. Okay, and what is object-oriented programming? So according to the definition of Timothy Budd, it's a programming paradigm based on the concept of object which can contain data in the form of fields, often known as attributes, and code in the form of procedures, often known as methods. A key feature of objects is that an object's procedures can access and often modify the data fields of the object. In object-oriented programming, computer programs are designed using objects that interact with each other. And of course, I put the link to the book in the description of this video. Okay, but what is object-oriented programming in simple terms? It's a method of writing programs where programs are created from objects. Objects combine data and actions on that data into a single entity. It's like creating models of real-world thing where each object can have characteristics and can perform actions. Object-oriented programming helps organize code in a way that makes it easier to understand and modify. And I wanna know, have you ever encountered object-oriented programming? And if yes, when and where? Let's talk briefly about how has object-oriented programming developed. Object-oriented programming had been founded in 1960s. The first encounter it was the language Simula, and in 70s the concept of methods had been implemented in the first full-fledged object-oriented programming language, which called Smalltalk. In 80s, it was the time when the C++ and the fundamental works in object-oriented programming had been created. And since 19th, object-oriented programming had been completely dominant paradigm all around the world. In the beginning of the new millennium, Java and C++ became the gold industry standard, and other object-oriented programming languages are gaining popularity, such as C# or Python. In the beginning of second decade, JavaScript became the front-end standard, and the role of solid principles had been increased by worldwide usage of object-oriented programming. And of course, we got the rapid development of cloud computing systems. And today, object-oriented programming continues to dominate, and it's widely used in all areas of software development. Okay, and how does object-oriented programming work? Let's compare it with the functional paradigm. The functional programming paradigm tells us that we need to describe our functions. And let's imagine that we have a task that we need to calculate area for two possible shapes, for a circle or for a rectangle. And let's briefly have a look to this diagram. We have some data input, and we send it to our first function, calculate area. Within that function, we need to understand for which shape we need to calculate our area, for a circle or for a rectangle. And then we need to call the proper function and got our result. And now let's have a look what does object-oriented programming provides to us. OOP proposes us to describe our own custom types and their methods, which would work with our data within our objects. And let's have a look on this diagram. We have our type rectangle. It's like a template for our future object. And this template refers to the calculate area method, which works with the fields of rectangle object. Then, if we want to create a rectangle, we need to put some data in our template and the object will be created. And let's make it simple. When we try to create our own custom types, it's the same like we have standard Python types, which have some built-in methods like lists or strings or sets, and we have a lot of built-in methods such as sort, upper, remove, add, lower, union, etc, etc. And our task in object-oriented programming is to create our own types and our own methods to work with. And of course, object-oriented programming is good in moderation and in skilled hands. And the advantages of object-oriented programming, it's modularity, code reusability, extensibility, and abstraction. And of course, object-oriented programming has disadvantages. It is complexity and overhead for simple tasks, resource consumption, steep learning curve because it's one of the most difficult topics in programming, and scalability issues if you do not maintain your code properly. And before we go to the coding, I propose you to join our repo in GitHub, and there you can find a lot of useful materials and this presentation. And now let's do code. And let's have a look to the solution of our task with the functional paradigm. Here you can see the function calculate area. The main role of this function is getting the shape, and according to the type of the shape, to call the proper function, such as rectangle area or circle area. And you can see that here we have some sort of if-else branching, and try to imagine what should we do if we would have more and more shape types. We need to change this code. And let's have a look to the structure of our shapes. Here we can see that we use tuples as a structure to store the data about our shapes. And what I don't like in this program, I'm not sure that is a good idea to keep our data like that, because we can work with a very different types of shapes, and that's not convenient to keep the parameters like that. The second problem, as I said before, a lot of if-else options. And the third moment that I need to keep in mind indexing of my shapes, and remember what is the meaning of the precise element of tuple. Of course, somebody can tell me like, hey, we can use dictionaries. Okay, let's go and check the solution with the dictionaries. And here you can see that we use the precise key for type and the precise key for parameters and radius or length. But anyway, the code looks creepy, and we need to be sure that we always have this key in our params. And let's go and see what object-oriented programming proposes to us. Here we have two templates, two classes for a circle and for rectangle, and we encapsulate the storing of our parameters within the fields of our object. Furthermore, we encapsulate all of the logic for calculation area and even for calculation perimeter as an additional option within our class circle, and the same we have for rectangle. As soon as we create the new rectangle or the new circle, we can call the methods of calculation area or perimeter directly from our object. The same like we do when we want to append a new element to a list, or when we try to replace one symbol to another in a string. Let's have a look to the list of shapes. And now it looks more than convenient because we see our custom types, and it would be much harder to mix up with the parameters because we can use the keyword arguments when we try to create our object of rectangle or circle or whatever. And let's check how many if-elses do we have in this code. None of them. Furthermore, we have an additional logic of calculation of perimeter for each of our shapes. We don't have any of this functionality in our previous examples, but the code base has the same size. More functionality, less size, profit. That's all what I want to tell you for today. Like and subscribe. See you.